Well, good morning and welcome to Laser Scanning 101. My name's Phil Higgins and I will be your moderator for today's session as we take a close look at laser scanning, the process in construction and the activity of this high definition surveying that we are now seeing so prevalent on many construction practice activities. I'd like to introduce you to our panel of experts today. Joining us is the contract manager from Alec Contracting, Mr. Hennie Vermeulen, and he's joining us from the United Arab Emirates. Hennie, thanks for joining us. We also have the head of BIM strategic projects for the Kier Group, James Franklin, and he is also joining us. Well, no, he's joining us from the UK. So very much appreciate your joining us all the way from the UK. And we have the head of digital solutions for JLL, Mr. Mark Hamilton. Guys, thanks for joining us so much. We look forward to breaking down and understanding a little bit more about the laser scanning process. And don't forget that it is a 101 lecture or a discussion point. So I'm sure that we have many from the industry joining us who may need to understand a little bit more about this process. Well, laser scanning is fast becoming a very popular land and construction survey method. And this can accurately measure and collect data from objects or surfaces, buildings, landscapes. And as much as there are many construction companies today that are really adopting this technology as an in-house procedure for their construction process, as well as we're seeing the development of a lot of specialist consulting services or service providers. But laser scanning isn't really a new technology. This is not something that was just recently invented, but it is a really good example of how technology has evolved through the development of specialized equipment, software capabilities, and data processing speed. The history of laser scanning dates back to the 1960s, and initially equipment was very basic, consisting of cameras, projectors, and lights, and these first scanning systems took a very long time to process the data. In the 1985, these simple scanners were replaced with LiDAR systems that were more high-quality scanners that used laser beams and shadowing to collect data related to objects and surfaces. And so that was then, and since 1985, we've seen steady and continual increase in the development of the technology. So how does this look today? What are some of these systems that we are using today in the construction process? I'd like to hand over to Hennie and ask if you could talk to us about some of the types of the laser scanning systems that we are seeing used in our construction process today.
Thanks, Phil. Yeah, just out of a point of view from Alec's side. So our vision of Alec was to go digital and go paperless. So basically, we've been using scanners for the past 5 to 7 years, and only recently, the last 2 years, we've actually been driving to make use of these type of scanners to our benefit. From the start of actually doing the setup of active construction up to the end where you produce your as-built. So for that, we've done research, and we found that we use multiple devices, some just for setting out, but mostly it's static laser scanners, where we actually we try to complete the whole process from taking the BIM to the field, and then from the field getting it back into the BIM model. We found a lot of benefit, which we can discuss a bit later. But yeah, we've been actively using it, and actually from the end of 2019, we've actually made a sole project just going digital with these scanners. So we're using it especially on the laser scanning. So yes, we are using it.
So for Alec, this has very quickly become just a standard process in the construction activity?
Yes, we've actually done we did a business process re-engineering on actually on bringing the as-built from the site back into the model. So we've mapped all our processes. We actually went through and checked every single set, and then we just we found there was a massive saving, especially on time. Yeah. and time leads to money savings, but especially on time. That's our biggest win.
Okay, thanks so much. James, talk us through the equipment that's used to collect this data. How is this scanning technique work? What's the process?
Okay, well, there's various different pieces of equipment you can use dependent on what you're trying to achieve. But basically, you'll have a scanning device which you'll host on a tripod, or you could even host it on a drone. And that device will then capture the work site using lasers and create a 3D map of that site. I think the interesting thing is that, as you say, this is becoming much more an easier solution to adopt, because, as you say, the technology is getting easier. So I can remember back in 2008 when I first saw a scanner on a work site. A team of 5 people brought this huge machine onto site to scan the as-built conditions. We're now using systems which basically one person can pick up and be trained on to use within half an hour to capture site. So the technology is really becoming easy to adopt, and the workflow is much easier to implement on our sites.
So we're creating these data points from and creating a digital image of a site. Is the laser bouncing off a surface and recognizing distance?
That's right.
How does that work?
Yeah. So the laser is bouncing off the surfaces, and the machine is timing the return of those lasers to then give it a picture of how far things are from the laser itself, so that it can then create these 3D maps. So that's really basically how the technology works.
Okay, my little research explains that this is referred to as the time of flight. Is that, I read something about this? Is this?
Yeah, that's right. Yeah.
Time of flight. Okay, so we're measuring the distance and creating a myriad of data points. So what happens to this data from that point? We collect this data, then what happens to the data?
So it creates a point cloud, which is a huge data set of thousands and potentially millions of points capturing the work site, and that is quite hard to navigate. But what's really interesting now is that we have these design models via BIM, and we can use some computer automation and some workflows to now take a comparison between the work site using the point cloud gathered via the laser scanning, and then doing a comparison against the BIM model. And this can give us really good a check on progress on the site, to seeing how much we built in a given day, or it can also check build accuracy, making sure that we positionally placed everything in the correct position as per the design. So it's really given us a good build verification.
Mm-hmm. Oh, very good. So then is your company using this technology on a daily basis or for every project? What's the status with your company's use of this?
Yeah, as I say, I think there's many different workflows, and you need to pick the right workflow dependent on what you're doing. So as an example, quite a low fidelity system, but with high user engagement, would be Matterport. That's very much a consumer product. So we can go around the work site and we can create these navigatable 3D images, which is much like navigating Google Street View, which is great for client engagement and stakeholder engagement. But say if we were doing some work on a heritage building, we would employ high-grade surveyors using high-grade equipment to do very, very highly accurate scanning. So you need to select the correct technology for the application. But we are using it. It's very normal to use this type of technology. We don't actually buy the kit ourselves because you need to manage that kit, and we're not really set up to do that. The other thing is that you've got to keep that kit up to date. It's always changing. You want to be using the latest equipment. So you're
outsourcing this service to a provider?
On many occasions, yeah. Yeah.
Very good. Well, I'd like to come back to revisit the different workflows that you made mention to. But if I could just jump over to Mark for a second, because I'd like to hear from him what are some of the advantages that we're seeing of using 3D scanning technologies today in this construction real estate marketplace?
Yeah, so from our perspective, I think it's providing quite a lot of like end use value to clients. If a client has an existing site and maybe they're changing the use of that site, or they're developing a new site, it makes sense for them to have like a firm and accurate understanding of the site conditions, especially if they're going out to market. So if the client is able to either have a drone survey conducted, which produces the point cloud data, and then issue that as part of the tender process, it removes a lot of risk from the contractor. So that same principle would be applied if the client is owning like a brownfield building that they want to change the use of the application of. So I think those are some of the big advantages from sort of a construction perspective. And then of course, going into operations, having a digital replica over from the contractor provides huge value. So from our perspective, we've been engaged on the digitization of the King Abdullah Financial District, which was about approximately 33 million square feet, and that helped us really serving as sort of a PMC role. It produced the information and the point cloud data that could be used throughout the tender process to reduce risk for the contractor or the client. Sorry, and then so then another big application that we're seeing is, as James mentioned before, Matterport data. So that can be used in leasing to help that process, and then also for potentially asset register production. So we're doing one scope asset register production for the conversion of buses into boutique hotels. So Matterport is the technology that we're using for that. So we're performing the scanning, and then from that we're generating asset registers and tagging them to the actual physical assets within the Matterport link, and then putting a QR code. So I think a lot of applications within the whole real estate lifecycle has been changed and has adopted to sort of integrate with the scanning technology.
Is JLL providing this service today, or do you outsource the technical element and your consulting in this field, or what's your business?
So JLL is providing digitization services. We own our own scanning equipment, so we own a lot of Leica equipment. And then we also own our own Matterport scanning equipment as well. So the scanning equipment's a little bit different for both applications, but yeah, I mean, mainly for the large digitization project, we found it more efficient if we were conducting the work ourselves as opposed to managing the supply chain. So I think it's different for everyone, but I'm sure Alec and they prefer to have their own equipment so they can work it to their own processes. And I think that makes a lot of sense.
Hennie, I mentioned in my introduction that the early development of laser scanning had very long processing time, and new technologies and our ability to process that data is what's driving its success. But how quickly is the latest laser scanning process today? And do we still suffer from some, I don't know what you call it, latent rendering of the data through the software capabilities? Well, talk us through that a little bit.
Yeah, cool. So basically that was one of our first case studies we attempted. So there's two portions. One is the actual getting the data, and then there's the one processing the data to the as is condition. So what we found for the initial setup is the actual demand versus the machine. We had a lot of saving there. Like James mentioned, the setup, doing the actual scan, it depends what portion and how many points you want to scan. During that process, we found about a 70 to 80% improvement in process and gathering all the information. That obviously led to a reduced time frames on producing this information to process it. So that equated to almost $220,000 in saving time. When we went to the portion of processing, as you asked, we had a big challenge because one scan, for example, takes 40 GB. So to process that between your surveying department and your design department, that's going to stitch and join the files and send it, produce the actual as-built. Sharing that file was a big problem. So to have the right supplier or the assistant software, we actually reduced the file with 90% to a 2 GB file. Makes it easier to share and work with. And that reduced our time with about 30% in the process. So in the input and the output, actually, we gained a massive saving in time. So no, I think if you don't go and explore or map the process and see where's your problem with the processing, and not engage your suppliers to provide you with the right software, you're gonna actually struggle, and it's gonna actually almost be the same duration you're gonna spend to produce it, even though it's digital. Yeah. So yeah, you need to go and look at all the steps. Yeah.
I think
actually, Hennie, I was going to say that's a good point, because when we commenced the large scale scanning project, we were actually proceeding with completion of the scanning, and then we found out the processing was what was up, which we never thought it would be the processing, and then we had to procure additional equipment. So
yeah, we went, Mark, we went a 3-week workshop just to understand, because the supplier couldn't understand why we're taking so long, because there's actually the cable from that Leica machine, plugging it into your computer, that transferred like 8-9 hours, and just if you've got a software, it just converts it immediately and problem solved. So just something as simple as that makes a massive impact. Yeah.
Well, back in the introduction of this technology, my computer had a hard drive that was about 20 megabytes. We were excited to have a hard drive of 20 megabytes, and then they brought out a 30 megabyte hard drive. That was even very exciting. So we have definitely come a very long way. But what are some of the additional services that we're using with this technology? I know in our discussions earlier, we were talking about drones, and I think Mark's excited about this technology because he gets to fly drones or something. But well, how do we go about with collecting this scanning data on a particular site? What are some of the processes that are used? James, what are you seeing over in the UK?
Yeah, well, you mentioned drones. So on one of our sites at the moment, we're building a super prison, and we're having monthly flyovers via a drone, and that's creating a point cloud. And we've used that to monitor the cut and fill, because we get closely regulated on how much material we're sending to landfill. So it's really helped us to keep a tight control over that. But also what's quite interesting is, and it comes back to what Hennie says about the file size, is that we have a high definition point cloud, which we keep on file should we need it. But we also have a reduced point cloud file size, which we are then able to share via our Deluxe system, which we use for our field BIM, for our quality forms and model viewing. And we're able to share that with all project stakeholders, so they're able to see the point cloud overlaid against the BIM design models, and it just makes it very accessible to all. What I think used to be the problem historically was that we could gather all this data, but it was only those with the high powerful machines that could ever access it. Now we can make that information accessible to all. So a really good record of site there, creating a point cloud from a drone.
I understand that there are 3 types of laser scanners or scanning processes today. I'm not an expert in this, but I did do some research so that I could ask questions that I knew the answer to. So help me out here. We have phase shift, time of flight, and triangulation. Do any of you technical experts have some comment on these? What are some of the references that we're talking about here in this area of scanning and technology?
That's kind of the surveying technology behind how the laser works, I guess, Phil. Probably not my area of expertise, but.
Okay, but there's some specific elements that this technology has been referred to, but we are using a combination of these within the construction space. Is that understood? So what are some of the applications where we're using digital scanning today? Mark, what are some of the specific projects that you've worked on?
Yeah, so I think, I mean, if I would like look into the first question, I would advise that like a lot of us are working within the business applications of scanning and how we utilize scanning to improve, you know, our business functions. But really looking down into the technology of the scanning requires a very robust technical background, such as like masters in geospatial engineering, to actually understand how the details of the LiDAR scanning equipment and different types of it. So I think yes, it gets quite complex from a business application. Yeah, I mean, as I mentioned before, so it can be photogrammetry data to generate asset registers, using point cloud data in order to quantify site conditions before going out to the market. Another one we're doing now on master planning is using drones to capture point cloud data and then actually setting up a digital replica of the master plan and then importing the specific BIM models into that master plan, but overlaid onto the actual point cloud data or 3D mesh. So I think those are sort of the main scanning applications, at least from my perspective, which is so my perspective isn't as much geared into design and construction, but more into management.
Okay. All right. Well, I have a few more questions for you guys, but I just want to mention to the audience that we have a question and answer time in about five or 10 minutes. So if you have any questions, then please just use the Q&A section there on the platform to send a question for any of these guys. If it's a general question for the panel or a specific question to any of our panelists, then please make use of that. And so what are the costs associated to the implementation of laser scanning today?
So from my perspective, I think the biggest upfront cost depends really on whether you're performing the scanning yourself directly or you're engaging a third party to perform the scanning for you. If you're doing it directly, obviously you need the knowledge and expertise, but the equipment is becoming more user friendly. And then the biggest upfront cost is really purchasing the equipment. For some of the high end scanners, you're looking at prices that are close to $100,000. But then, you know, you can go cheaper with the cameras that are the scanners that are applicable for the Matterport purposes, and they go down to $3,000 to purchase those scanners. I know James and Hennie, your thoughts on, you know, other ways of having the service performed.
Mark, I would say if a company is new and trialing this out, maybe they can hire a $70,000 machine for maybe $500 a month. I mean, for a startup, they can trial it for 3 months, and if there's benefit, definitely you need to buy. I mean, we've got multiple machines. Like you mentioned, you've got the small BLK up to the big P30, P40s that actually goes 150 meters or longer or kilometers. So, I mean, it depends what you do. Also, how congested is your project? What's the detail? So each machine device actually tells you the requirements. So there's so many devices. I mean, I think for training, once you buy or rent the equipment, they always offer the initial training. So, I mean, people shouldn't be scared to use it. Yeah, and it's definitely the way to go. Definitely.
I mean, if this is the case, then the return on this investment is reasonable. How would you qualify that return on investment? What are some of the savings or efficiencies that you're seeing with the implementation of scanning in your process? James, do you have an answer on this?
I have an example, Phil, which I can share. So just going back to how we've captured the earthworks at the prison that I mentioned earlier, using a drone and laser scanning from a drone. Basically, we're able to capture that site within half an hour, and using terrestrial traditional surveying techniques would have taken a team of 2 people about 3 days to capture the whole of the site. Not only were you taking people out of a dangerous work site where a lot of earthworks machines are potentially working, but it's working out a great deal cheaper than having 2 people on the ground for 3 days. So we're actually getting a cost saving from doing the survey. We're doing the work safer, and we're getting better information. So it's a win-win-win. That's just as an example. I mean, another thing I think that I find quite encouraging as well is that some of this stuff is getting easier, as I mentioned earlier. But I used a piece of equipment the other day, and it not only was a total station or a theodolite in old money, so we could do your setting out of your works, but it also had a laser scan built on top of it. So it was a one-stop machine. I could not only set out the works, but I could then do the laser scanning. And I'm an engineer of old, but I haven't touched a theodolite or a laser scanner for quite a long time. But I was able to pick that up and work with it very quickly. So really encouraging to see that the technology is becoming really easy and accessible.
Very good. I used to use dumpy levels. Do they still call them dumpy levels today?
Oh, yeah.
I always thought that was a strange name, but very, very good. Well, good to see we still have some old technology working with the new technology, but I think the day will fast come when we are able to integrate this into our business process. But this area of data collection and the volume of data seems to be a concern. There's a couple of questions from our audience today already. One saying that they use scanning technologies for the oil and gas industry, and one project is a 50 gigabyte file that just simply won't run on their computer. How are you guys managing this process of such high volume or high quantity of data? Mark, what's sorry, Hennie, what's your experience?
Yeah, Phil, that's actually what I mentioned earlier. So besides I think our biggest one was the software conversion or compressing the file from 40 GB to a 2 GB file. That was the one winning. Obviously, I think you need to look at your laptop or your PC. It needs to be a DD drive. It needs to be you need to definitely give it much more memory, virtual memory, and also the memory on the actual unit you're using. So you need to beef up your hardware dramatically because it's carrying a lot of files. And obviously, you need to have the software. With those two, we've done that. We've actually got the guy here today on site. So yeah, and he's doing it with much less effort. Yeah, very successful.
Who are some of the leading suppliers of the equipment today, Mark? What are some of the major brands in this space?
Yeah, so I mean, when we assessed the market, we found that, you know, for our use case of sort of high productivity scanning of buildings that were partially constructed, we went with Leica RTC 360, and those are very fast in processing. Before, we were doing some experimentation with the NavVis scanners, but we found the RTC 360 to be optimal for our use cases, and then we went and procured an additional few of them to finish that job. So we're very happy with those scanners.
Oh, that's top range, huh? Yeah.
So we have some leaders in this space. Is there new players that are entering into this marketplace, or are we just seeing the development of the old?
I mean, for me, it's pretty interesting what's going on. We hear a lot about like scanning robots that are sort of going around the sites, and I know there's been a lot of talk about this as like a newer technology. And I think it's been publicized, but I haven't seen so many applications of that. So it will be interesting once that technology is available. Maybe Alec are in the process of developing it. So
I think Hennie works with the same outfit that we work with, Scaled Robotics. Isn't that right, Hennie?
Correct, and that's that walking robot. Yeah, we haven't seen
the Doxel one. Is that what it's called?
Waiting for that one. Yeah.
Yeah.
So we hear a lot about the use of drones with this technology. How do you contend with, especially in the UAE? I know there's a lot of regulations for the use of drones in the city area. I'm sure it's the same everywhere around the world or around airports, that kind of stuff. So what are some of the concerns that you've faced with the use of these supportive technologies?
I mean, in the region, like for example, scanning in Riyadh, Saudi Arabia, they have a pretty lengthy approval process, and it can take up to 1 to 2 months to get approval from the General Authority of Civil Aviation. So yeah, I mean, we've faced that on some of the scanning jobs, and we found it a little bit difficult to get our own team licensed for drones. So there's approved suppliers that are already licensed, so we found it easier to work with them. In the UAE, I'm not 100% sure because we haven't engaged in too much scanning work in the UAE.
What about in the UK, James? Do you face these concerns, issues?
Yeah, absolutely. Each drone flight needs to be planned, and we work with key supply chain who have the correct licenses and follow the right procedures to make sure they got clearance for flights. Originally, when this technology came about, we did debate offering it up internally, but in the end, we decided to go with external supply chain. They manage all the licenses, making sure that they've got the capability to work in the inner city, as well as at quite close quarters to buildings. But sometimes you just need to accept that you can't use a drone. For example, we're working on an airbase, and absolutely drone technology is not allowed there for obvious reasons. But in general, if you want to fly a drone, there's generally a way for someone can work out how to do it safely.
Mark, why don't you talk to us about one typical example, one project that you've worked on where you've been involved with scanning, and what was the outcome? Just take a few minutes to explain. I'm going to ask each of you the same question, so be ready with a use case. But we want to understand how this technology is really being applied in the construction space today.
Yeah, so I think, for us, the biggest use case would be project would be the King Abdullah Financial District. So the ownership had changed hands. It was approximately 70% complete, which was spread over the different 48 buildings, some more, some less. And they were in a state where the previous contractors, had been sort of off the job for approximately 2 to 3 years. They didn't have standardized information from when the contractors left the site. And then they were tasked with recommencing the construction and handing over a few of the buildings, quite urgently, and the rest to follow within 2 to 3 years. So for us, so performing that scanning work, and then so we did the point cloud scanning. In the beginning, we were utilizing a third party to handle the scanning for us, and then we found, as I mentioned before, a few issues with processing that was holding up our supply chain. We went and ended up procuring Leica RTC 360s. We procured 4 of them. We had a team of maybe 5 to 6 guys working approximately maybe 8 to 6. And then we pretty much finished all of the scanning, relatively quickly. And the processing was no longer a limitation, which was a huge relief for us, because having a limitation where you finish the scanning, but you don't know the status of the processing is extremely difficult if you're trying to have BIM produced from the point cloud data. So that was a major issue for us, and it was mitigated by the Leica scanner. So from our perspective, that was great. And then we produced BIM, and then that BIM information was issued as part of the tender. And then during that time, 7 of the buildings were completed. And then the BIM for those 7 buildings was then developed into operational asset information models, and then integrated with the operational software. So the whole headache of not having standardized as-built was completely removed from the end client, and they were able to integrate and implement their operational software systems.
Are your projects mostly for a developer or a project owner, or are you working with...
Typically, yes. So JLL, we're typically providing our services for the end user. Yeah, the owner, the developer. Yeah.
Very good. Thank you so much. Hennie, what's one example, an interesting example where you've used this technology?
Okay, Phil, yeah, so I'll use the example of the Dubai Hills Mall in Dubai. So what we've done, we actually wanted to fast track the submissions or the as-built drawings. So initially that's only given right at the end of the project, putting a lot of constraint or strain on the people providing this. So we actually, what we've done, we had an initial 24-month period to do all these. Basically, it's 600 shops, outlets that we want to actually produce this grey box or this MEP, this as-built. So what we've done, we've crunched it into 6 months. So a massive saving. They're doing them a bit later, but doing them quite efficient. And it's there was much less effort than the planned 2 years that was initially. So again, a massive saving in time. And the rejection rate is almost is zero. As-built is an as-built. You can't contemplate that. It's the image, like they say, that model of market captures 2 million points a second. So I mean, it's amazing detail. It's very accurate, and it's a good investment.
James, what about you? What's a project that you've recently worked on with scanning?
So yes, scanning. Well, I think it's really interesting how it backs up our approach to modern methods of construction, particularly off-site. And a really interesting application recently was where we were creating buildings using precast concrete to drive efficiency in the build. And then we were also using prefabricated risers. Now, in the precast concrete, we created voids for the risers to be inserted. These risers were 18 meters tall, so very complex lifting procedures in place to put those in. And we wanted some assurance that the risers would be able to fit in the voids. So we scanned the build, and then using the scaled robotics platform, we then did a comparison between the scans and the BIM models. And then we were given that assurance that we had the tolerance to be able to drop these risers into the voids within the precast concrete. So that was a really good application of scan technology backing up a modern methods of construction approach.
So is the drone scanning capability very accurate today?
I think it's accurate enough to for earthworks, certainly. You know, you're getting something like 20 mil accuracy from the drone, which I think for earthworks is generally good enough, giving you a really good idea of your topography on site. Probably comparison against, build design, probably you want to be employing terrestrial scanning there for the higher degree of accuracy.
I have 2 questions left. Thank you very much, James. Great answer. Hennie, where are you? How are you taking this data and implementing the data with other technologies like BIM 360, three-dimensional drawings, that kind of support for construction process? Are you working with this area?
Yes, yeah. So basically, we're using these scans as well to update the IFC model, the BIM model. So we're firstly updating the model. We're checking for deviation analysis to see if there's anything deviating from the IFC. We also use this as a coordinating tool within BIM 360 and all Rivet models. So it's easier between the team to collaborate, produce the asphalt drawings. Yeah. So we definitely use it there.
Okay, very good. And my last question to Mark. In 10 years' time, when we're having the Construction Technology Online Forum in 10 years' time, and we start talking about laser scanning, what do you think we'll be talking about? What is the future development for this technology in space?
I mean, I think just based upon where the rest of the industry is going, the rest of the industry is developing more efficient ways to receive point cloud data and to manage the size of the point cloud data. So as I sort of alluded to before, there's ArcGIS Pro, which is an Esri product, now receives point cloud data and receives BIM data. So you can import that and you can overlay it across a city map. So I think you're going to see more and more full cities that are like geospatially mapped, and the softwares are now being developed that they can receive that data. So I think with scanning technology, I think you'll see like a digital replica of the spaces, and of course the scanning will come down further in price and in ease of use. So I think, I mean, that's sort of where I see it going.